donate one hydrogen. And I believe there's an example of that on the worksheet also.
Right, and then H2 would be second.
It would be the second one, yeah. Okay. All right.
Yeah, no.
Yeah. Good. All right. Okay, so let me cross out a bunch of stuff here.
For this will they always give us the three
PKAs, yes, they will give you the 3 PKAs. All right, good. Oh, I'll use this chance also to kind of point out something, but you guys should be able to figure it out, especially if you study the charge diagram stuff with amino acids. If I'm given the following forms of phosphoric acid, I just said that each drop in hydrogen represents one of those pKa's, right? Let me write down the pKa's again. This first drop in hydrogen is represented by a pKa of 2.15. This one is 7.2, and this one is 12.4, right? Well, if the pH of the solution that phosphoric acid was in, if the pH of the solution was about a 1, which of these forms of phosphoric acid should exist in that solution? If the pH is 1. H3PO4. It gets slightly more annoying than that. You have to read the question specifically. There will be 2 types of questions here. One, if it asks which is the predominant form of phosphoric acid found at a pH of 1, the answer would just be H3PO4, because at a pH of 1, you're right here, it's less than 2.15. The predominant form is H3PO4. Okay, I'll stress that again. The predominant form is H3PO4. However, if it instead asks which forms are present at all, the answer is both this one and the one right next to it. Okay, so I'll stress that again. If the question asks what form of phosphoric acid is present, not just predominant, which ones are present in your solution at a pH of 1 in this example, not only do you pick the predominant one, you pick the second place one. Okay, you pick whichever one is pretty close to a pH of 1 also. Let me give another example. If it's saying you are at a pH of 13, and it's asking which forms of phosphoric acid are present, there would be 2 answers, right? At a pH of 13, the predominant one would be PO4, right? As drawn on here. But if they're just asking what is present, you also pick what is in second place, which would be this one as well, okay? There's a general chemistry reason for that you don't need to know, so I'm not going to bother explaining it. Just for this situation, if they're just asking which forms are present, you pick the one that is predominant and the second place one. Yes?
Would there be a time when they would ask which forms are present, but there would only be one answer, like only one?
No, well, technically, but biology, it's impossible. So the only way there will be ever one present is if you go to like a really extreme end of this. Like, now I'm not saying pH of 1, I'm saying like pH of like -10. It'd be impossible for there to be the second place one. And same thing over here on the right. If we're talking like a pH of 20 probably, there will only be a PO4 there. Okay? All right, so again, read what it says. Is it asking predominant or what is just present in general? Yes.
So if he gives the pH, it's going to be in between.
That would be annoying, wouldn't it? He won't do that. He'll give you either the left end or the right end here. Okay. Other questions? All right. Okay. Oh yeah, also, and this is a memorization thing, somewhere in chapter 1 and 2 notes, they talk about weak intermolecular forces and why they are biologically important, right? There's like 4 bullet points there. Make sure you know, fact-wise, it's a memorization thing, why weak intermolecular forces are important for biology, right? It might even be in chapter 1, I think. They give a lot of like introductory biology facts that you need to know. Make sure you know those facts. Like why weak intermolecular forces are necessary for living systems. What are the properties of life, right? The order and direction and all those fancy vocabulary terms they have in Chapter 1, be able to pick them out in a multiple choice setting. Obviously, you aren't going to be asked to define any of them. Be able to understand what are the properties of life, what are the properties of weak intermolecular forces that allow life to occur, those types of memorization things. Okay, yes?
On the Chapter 1 question, you said, what are 3 types of hydrogen bonds?
3 types of hydrogen bonds.
Kind of like a little bit.
Okay, I know what he's talking about. I actually don't know if that'll be on the first exam. Okay, so 3 types of hydrogen bonds. Oh wait, no, I'm thinking of something else. 3 types of hydrogen bonds are, you know, OH, NH, and FH. So it's what I covered earlier. Yes. No, it wouldn't be one. So he has that probably from an old version of the exam. So don't worry about that. Hydrogen bonds, biologically speaking, can only be NH and OH. I promise you there won't be any FH stuff. Okay. All right. Yes.
I was kind of confused about like the percent dissociation questions, like one.
Yeah, he gives you like ratio and then percent dissociated stuff. He doesn't ask those anymore on the exam, so don't worry about that format. The format of Henderson-Hasselbeck questions he will ask will be the ones that you see me put on the worksheet. That's the format that he gives you, most up-to-date version of those types of questions. Yes?
So I guess for the Henderson-Hasselbeck, this is on the homework. It would say like the total liters, and it would ask you to derive something from the total liters or something.
From the total liter, like total volume or something? That's a lot harder. You won't have to worry about that for the exam. If you want to know more detail for that, you can come during office hours for me to explain that, but that's just the extra credit homework thing. That won't be on the exam. Okay. All right. Let's see. Oh yeah, let me pull this up. I can't remember what chapter it is, but one of these chapters gives you a bunch of enzymes and pHs. Is it chapter 4? Yeah. Oh, wait, here we go. This is the one that I'm talking about. All right. Take a look at these different enzymes. Enzymes, it turns out, which are things that catalyze reactions, have their optimum pHs that they work best at. And they differ depending on their pHs, and that specializes their function on where they best have activity, whether in the stomach or whether in the small intestine, right? If you're looking at this, of your options here, the one that is probably going to be most likely to be seen and active in the stomach, which is a very acidic pH, is probably going to be pepsin, it looks like, right? Notice that its peak, its optimum activity is at really low pH. How about the small intestine? Huh? Oh, there's a seat back there if you want to use it.
Oh.
Somewhere back there. So, to continue with this, what about the small intestine? So what we mean by small intestine is that in the duodenum, which is the very first part of the small intestine right after the stomach, it needs to counteract the acidic pH in the stomach. So by small intestine, we're talking about higher than average pHs. So what enzyme is more likely to be active in the small intestine? It's this orange looking one, which is pancreatic trypsin. Okay? That one is more likely to be active in the small intestine. All right? And I think he may have given another example or something in class. Review your notes. There's somewhere that mentions what enzyme can also be seen in the small intestine. Yes?
There was something about like how in pancreas the CO2 helps to counteract. Do we have to know that?
The CO2 helps to counteract. That seems a little too vague. No, I don't recognize anything like that. Yeah. Hmm?
He said that in like lecture.
Yeah, I think probably, and I don't know if it was in this part of the lecture. If so, he's just talking about the reason why some of these enzymes can resist certain pHs. You don't need to know why for the exam, just that, you know which ones are more likely to be in the stomach and which ones are more likely to be in the small intestine. Yes?
What about that hyperventilation, how he asked?
Oh yeah, the hyperventilation. Is that this part? I have that note somewhere. Make sure. Yeah, okay. So let me talk about one other thing, and then we'll talk about the hyperventilation. Is it here? Yeah, here we go. This slide sure it's still recording. This is in chapter 2 near the end where it gives you a couple buffers that are important in our bodies. You do need to know visually, if it gives you a multiple choice answer, what is an example of an extracellular buffer? That is this one here. This is called the bicarbonate buffer system. There might be other names also, but I call it the bicarbonate buffer system. The one down here is an intracellular buffer system. In other words, that buffer is important only for intracellular activities inside the cell. This bicarbonate buffer thing is very important, especially when we talk about medical conditions like hyperventilation, okay? What hyperventilation is, you recognize it when you see someone doing is they're breathing in and out really quickly. And if that continues, they're going to pass out. What do people do to alleviate hyperventilation? What do they try to do? They breathe in and out of a bag. The reason why they do that is all the CO2 that would be exhaled, they're trying to put it back in their bodies. So that is this CO2 right here. When you hyperventilate, when you put a bag over your mouth, you're trying to bring the CO2 back into your body. What that ends up doing, as you look at this picture here, more CO2 means you have more H2CO3, and in the end, that means in your body you are increasing the amount of carbonic acid, of HCO3 minus. Yes, question? Don't worry about the pHs. Just know what is the extracellular one, what is the intracellular one. So again, when you hyperventilate, you have a bag over your mouth, you're inhaling CO2 back into your body, you create more carbonic acid in your bloodstream. Predict then what is going to happen to the pH of your blood if you do this bag thing. It's going to lower because you're making your bloodstream more acidic, and that you're doing that on purpose because if you were hyperventilating a lot, the pH will increase instead to the point where you have issues. Okay? So again, you breathe in the CO2 from the bag and it makes more carbonic acid, which lowers the pH of your bloodstream. Yes?
So when someone hyperventilates, the CO2 goes down and then the acid becomes more basic?
If you're not doing the bag thing, yes, you're releasing CO2 too fast, so you're going to have less carbonic acid in your bloodstream, so the pH is going to go up because there's less acid in it. Okay. All right, so that's the hyperventilation thing. Oh yeah. Where's that special buffer here? Somewhere around here. Yeah, and serine. Make sure you know where you find that as well. The extracellular buffer is example was given. Intracellular was given, and serine. Where would you find that as well? Yes. Question.
So whenever you're doing the bag and you're inhaling the carbon dioxide,
yes,
that makes your blood more acidic.
Yes, and that is because if you look at the picture here, if you inhale more of this CO2, you're going to make more of this carbonic acid, which is more acidic. Okay. All right. Good. All right. Metabolic enzymes. We basically covered all of chapter 1 and 2.
Can you go back to the end?
Yes, you need to know not the structure, just the name and where it's found. That's it.
So just the brain?
Neurons is probably more accurate, actually. I didn't realize it didn't say neurons, but neurons is probably more accurate. All right, a couple more things for chapter 1 and 2. Oh yeah. Is this chapter 1 or 2? The ice and water diagram. This one, this one. If you are given this graph on the left and you're given multiple choice answers, all it will be is interpret the graph. Which statement below is true or false? So basically, as long as you know how to read a graph, you should be fine, even if you don't memorize this thing. Okay? I'm not going to go over it. It should be very simple. You won't have to memorize that graph. Just if you see it, make sure you interpret it. And a lot of this interpretation you should know already is the fact that ice is less dense than water. That's kind of one of the core things that this graph is telling you. I won't go into more detail than that. Finally, enthalpy. Oh yeah, my cells and liposomes and enthalpy stuff. So, my cells and liposomes. You need to know the small difference between them. And I'm looking for a nice picture to give you. Here's a micelle. So a micelle forms when you have a nonpolar molecule and you throw it in water. And notice that water